Let's look at the data collection principles. We're going to look at these following key concepts. And the first one we want to look at right now is uh, defining a population. Now, this seems somewhat obvious, but reality is a lot more to think about here when we define a population. Right? So one thing we can agree on is a population is all that is understudied. And notice I kind of kept this vague. Um, it can be objects, people, but the reality is we may just be interested in particular measurements. Okay, so when we look at people, often we just measure something about a person. Or if we're looking at some object, we're measuring something about an object. So, our population or say our measurements belong to a population of all possible measurements. So the population really contains everything, right? Compare that to a sample. A sample is a subset of the population. Okay, so we want, again, the sample is just a subset of population. Ideally, a sample is a representative of the population. So the way that a sample can be represented population is if the sampling process is unbiased. And we'll talk more about this as the course progresses. Now, I'll just make a mention of this right now, that no sampling process is perfectly unbiased. So we're not looking for perfection here. What we're looking for is a sample should be good enough such that if we make decisions based on the sample, the results are useful. Okay. What is a summary? A summary is a single value or values, sometimes there's more than one, that capture the data, and the data being our measurements. So the one that you're more familiar with is an example is an average. The whole point of an average is to really capture the singular parts of the data. So, for example, if you said, on average, I can make $18 an hour selling something on the market, then that number, the average, gives you an idea of what the individual values that you can see look like. Okay, so an average is really an example of a summary. And then we have this other issue, quantitative data. Quantitative data can be measured using numbers. But it's more than just that. It's not just being measured using numbers. So that mathematical operations on those numbers makes sense. For example, if I looked at your zip code, like where do you live? Well, that is a form of data, but the zip code, I can't add this individual zip codes. It makes no sense to divide zip codes. They're just they're numbers, but mathematical operations make no sense on those. Uh, okay, so that's quantitative data. Categorical, there's another one more here called categorical data. And what is categorical data? Well, categorical data is just that the data becomes it's a category. So a zip code is a form of a category. If you're looking at hair color, you just all you can say is so I can say it's brown or black or blonde or uh, red or any other way we can describe hair color. In that case, that's a form of a category. So often we think of categories as being described in words, but sometimes that's not true. Sometimes they're described by numbers, but again, the difference is those numbers, when adding and subtracting and multiplying, make absolutely no sense on those numbers. So, but we're going to stick to something not too confusing. All right, so let's look at a couple of examples here. Yeah, let's look at a couple of examples here. A study over the age of men over the age of 50 at OHSU looked at 3,455 patient records. Looked at cholesterol levels and milligrams per deciliter for those patients. What is the most likely population under study? So again, from this description, I would say population under study. Would be all men over the age of 50. Now, notice how much difficult this really is, defining a population. Another thing you want to understand is populations. A population is user defined. Okay. So meaning that the user can say, no, this is the only thing that our study is focused on. Nobody else, nothing else, no other object, just these objects that we're about to define. And for example, this seems pretty clear cut from this description. All men over the age 50 is population under study. But let me ask you this. Is it only in the US? As an example, or just a particular region of the US? Who are we talking about? So often, again, it takes a while to really define population. We're going to keep it, again, simple here. Okay. Again, what does this sample consist of? Well, the sample, in this case, consisted of so big question. Okay, so in this case, the sample just considered the 3,455 male patient records from OHSU. And I'll throw this in too. So, no, I'll throw the other as well. And what is the measurements and corresponding units? So again, that was the sample consist of 3,455 male patient records from OHSU. And what we're measuring is cholesterol levels. In milligrams per deciliter. Okay, so there's our what we're measuring and the corresponding units. So let me do this next. Imagine, and this is something you should do sometimes in class, when you're reading this, imagine the actual measurements not popping up. So again, maybe I don't know much sometimes about cholesterol levels. I've seen them when I have to also don't worry about cholesterol levels, but it could look something like this. Here's the individual data. Like with somebody, you measure somebody and they could be 200 milligrams per deciliter. Measure another person and they're 235 milligrams per uh, deciliter. Measure another person and they're 194 milligrams per deciliter, and so on, right? And this can keep on going until you completed your sample. Now, one thing to keep in mind here is when you look at this data, what's true about this data? These are obviously numerical numbers. And does it make sense to add, subtract, and multiply with these things? And the answer is yeah. For example, I can add these and it makes sense. I can take an average of these and it makes sense. So for that case, when we look at this data, data is, and I'm going to throw in a little bonus here, and continuous. And again, what does it mean by continuous? Meaning this, that all our instruments, of course, you can only read so much, finite amount of reading. But when we say continuous, it means that this can be it can be also a real number. For example, maybe our instruments can only read to the ones unit. But the reality, for example, the person that measured 200 milliliters, their actual value was 200.0347159. I'm just going to throw something here, milligrams per deciliter. In other words, a continuous number, this part here has no ending at all. It just keeps on going forever. So I can really write down any number when it's continuous, right? There's no breaks between the numbers. There's another type of number called discrete, and every single number is separated from the other. So anyway, this data is both quantitative and continuous. Under the same load conditions, how long does a Duracell battery last in hours? Consumer Reports conducted a study using 40 Duracell 1.5 volt batteries under the same conditions. What is the most likely population under study here? When you look at this, okay, what is the population study? Because, well, if you think about it, it's obviously all Duracell batteries. As a matter of fact, more specifically, all Duracell 1.5 volt batteries. Now, just again, to get a little more precise, this could be batteries that haven't even been produced yet, right? And also batteries that have been produced. Really, sometimes what we're considering a population under study, there's a lot that we're considering. And one of the things we're considering is that to populate the characteristics in the population under study are fixed. So whatever's making up the characteristics of that population, those things are fixed. So when we're doing battery production, well, we're assuming that the process that's being used to create those batteries is staying the same. Of course, there'll be variability, but that's okay. What is the most likely? Okay, get that. What does the population sample consist of? Again, 40 1.5 volt batteries. Okay, under the same load conditions. And what is the measurement corresponding? The life of the battery. And I believe, let's see, last in hours, so in hours. And again, that's the corresponding unit is hours. So notice there's really two populations here. It's just there's the actual physical objects, the battery themselves, the 1.4 batteries, all of them. And then there's a population here of measurements, which in this case consists of the life of the batteries in hours. Let's do this one more time. So again, if you imagine the data being produced here, for example, maybe one battery lasted 30.3 hours. Another battery lasted 29.5 hours. Another battery lasted 34.7 hours, and so on. So again, when you look at this data, I can see one thing, that it's going to be um, quantitative and numerical. Sorry, quantitative and also continuous. So just like the other one, it's the same type. Again, if you were going to take one of these batteries, again, we can only measure maybe to the 10th of an hour. Actually, I can do more with our technology. But for example, maybe the one that lasted 30.3 hours, reality is this was 30.3101597 hours. It's continuous in that this number can really, in reality, take on any measurement, which kind of brings a philosophical question, or, is this measuring time? Is time continuous or is it discrete? Does it actually have a stop? And I don't know the answer to that. But we think in everyday thoughts as this being continuous.